Boesmansgat, often called Bushman's Hole, does not look like the entrance to another world. It sits in the dry northern cape, surrounded by open land. From the rim, divers climb down a steep crater to what appears to be a small, quiet pool. Under that pool, the shape changes. A narrow opening drops like a chimney. Below about 60 meters, it opens into a chamber so large that a diver's most powerful light may not reach a wall. There is no horizon, no daylight, and almost no natural sense of up or down. The guideline becomes the map, the exit, and the only fixed point in a black void. Now place the bottom 270 meters below the surface, about 3 football fields, standing end to end. Down there, the pressure is roughly 27 times what we feel at sea level. A descent can take minutes. Returning safely takes hours because gases absorbed under pressure must be released slowly. Skip those decompression stops, and bubbles can form inside the body, damaging the brain, joints, lungs, and spinal cord. This was not simply deep diving, it was deep diving inside an overhead environment at altitude with no direct route to air. David John Shaw was 50 years old, an Australian, a husband, a father of 2, and an international airline pilot based in Hong Kong. Long before caves, he had built a life around controlled risk. He flew agricultural aircraft, worked with Mission Aviation Fellowship, and later piloted passenger jets for Cathay Pacific. He came to scuba unusually late. According to his family, he began after his son learned to dive, when Dave was in his early 40s, but he progressed with startling speed, from ordinary scuba to wrecks to caves to closed-circuit rebreathers and extreme depth. The pattern was familiar. Learn the system, master the procedure, then find the edge of what it could do. That matters because the easy version of this story paints him either as a fearless hero or as a reckless man who went too far. The people closest to him describe someone more complicated, charismatic, careful, intensely prepared, and deeply drawn to places almost nobody else could reach. As a pilot, checklists helped make danger manageable. In technical diving, he used the same instinct. He modified equipment, calculated gases, and planned failures. But a checklist can only control hazards you understand. At the bottom of Boesmansgat, the human respiratory system itself was close to becoming the weakest part of the machine. Normal scuba vents each exhaled breath into the water. A closed-circuit rebreather keeps most of that gas in a loop. It removes carbon dioxide with a chemical scrubber, measures oxygen, and adds only what the diver needs. For a very long, very deep dive, that efficiency is essential. The diluent gas can include helium, which reduces narcosis and is less dense than nitrogen. But no breathing mix escapes pressure. As a diver descends, every gas becomes denser. Moving it through hoses, valves, a scrubber, and the diver's own airways takes more effort. Think of breathing through a wide tube, then slowly making the air inside heavier while narrowing the tube. The diver can work harder, but eventually breathing harder stops moving proportionally more gas. And effort creates carbon dioxide. If the body cannot exhale that carbon dioxide fast enough, it accumulates in the blood, a condition called hypercapnia. The early signs can include breathlessness, anxiety, confusion, and loss of coordination. Severe hypercapnia can cause unconsciousness. This is crucial. A rebreather can still contain enough oxygen while its diver is losing the ability to ventilate. The danger may not announce itself with an empty tank. It can arrive as a feedback loop inside the body.